All right. Um, so just spent an hour replacing this injection molded component in a Sony f2.8 90 millimeter macro lens. Really great lens that I really like. But it failed on me. A little piece of plastic broke. I'm going to show you now what happened. I've got the broken part out. Uh, so let me just move this down a little closer here. Mm. Something like that. We'll get rid of the zoom. Maybe it's a little clearer now. Drop it just a little bit more. So well prepared. So, one of the things that I was struck by when uh, I started working on this is just um, just how complicated this little chunk of plastic is. Um, some of you are probably familiar with. I guess it's a trend around like maker YouTubers who talk about the type of plastic and how it was molded and over molded and all of that stuff. This is very obviously glass reinforced. You can actually see it at the surface level. And I'll do the classic scratch test. You can hear it. So this is the old part that I pulled out. I tried to super glue this thing when I originally thought or wasn't sure I would be able to get parts. See if I can get this thing to focus. Not really. Let's throw this into a different focus mode and see if that helps. So yeah, there we go. So I'm gonna just see if I can snap that back off. That's actually surprisingly holding surprisingly well. Maybe I should have just glued it and went on about my business. Holy crap. Um, wow. It did not break the acrylate like this. I used cyanoacrylate. It did not break that. It actually cohesively failed the glass fiber reinforced plastic again. That's amazing. So I should have just glued it and went on. Moral of this story. That was a perfectly fine fix. Anyway, uh, so this is the part that broke off. Um, it, you know, it's a little disappointing that the only thing holding the entire camera or the entire lens to the camera are these 4 screws that are, with these little offset bosses. But what was amazing, this is one molded part. And look at all of the features that are included. And when you're doing injection molding, there's features which are complex and you have to mill. This is obviously probably uh, you know sinker EDM'd is the only way I can imagine they made parts of this mold. But regardless, um, there is the complexity and the number of features which get milled into one or more mating faces of the mold, and then there are the actions which are you have the primary mold on this part. Likely it one one face of the mold comes in from this side, the other, the shell comes over the top, and then you have side mold actions. So these are additional pieces inside the mold that push in But then like this, if you had this part held like this, you wouldn't be able to eject the part because there's you know, this boss that made that hole there or there. Those pins have to inject, push in, you do the injection, wait for the plastic to cool, retract, and then you're able to eject the part. So when we look at this, I mean, the number of these features. So you've got at least 3 axes here because these are pinholes. They're on axis. The parts are square to the you know, they're normal to the tangent face of the ring. So those had to have been individual actions. So you got at least 3 there. 1, 2, 3. This feature here is also normal. So it had to have been a a 4th action. These look like they all could have come off the face of this internal mold, but you actually have this whole undercut ring here, which, you know, I'm assuming what happened here. These look like they're on the same axes, so this is probably all one action here. And there's some split, what look like might be split lines here where the entire mold, the whole outer shell might have come together from a couple of places. And maybe that's how they did it. I was looking to see if there were any obvious internal actions on the core of the mold. It's not obvious to me that there are. There's less, you know, blind recesses on this side, but it's still just incredibly complex. Just so many tiny little features. And I was just kind of blown away. I mean, this where this ring is undercut all the way around. I mean, that basically means the whole shell must have come together from multiple parts, mated with the back of the shell mold here. Obviously, the core comes in. I mean, it's wild. All these little pins that are locator pins for rubber isolators for the circuit board that drives the ultrasonic motors. Alignment pins for the lens element that drops down in here. It's just wild. And I just kind of wanted to share that, show what, you know, really surprised me that there's just that many features. Is that one? Yeah, that one looks like it probably came off this side too. This one comes off of this side. I'm not really sure how this works. Like, this was this way. That's at an angle there. So maybe that was an internal, there's an internal part on the core that pops out, and then this, whatever surface that made up these pins here mates to that out here. But still, it's just so clean, and yeah, it's just wild. So anyway, I just want to take a few minutes and go over that part. I mean, these lenses are very expensive. We think about the optics a lot. The glass itself is very, you know, technical, a lot of engineering in the glass, but there's also just a lot of engineering in the mechanics of these things, and it's no wonder they're not free. So anyway, just wanted to share that quick stream to talk about it. And that's all I've got.